Hey everyone, this is Mohammed Mustafa Ahmed, Embedded Systems Intern at Emertxe Technologies. In this video, I like to share you guys with my experience, the valuable insights, the learnings, and my journey at Emertxe Technologies as an intern. And also, last but not the least, the project which I made with Emertxe Technologies, which is washing machine. The goals of this internship include gaining knowledge in embedded C programming, learning the syntax, structure, and applications of embedded C as variant of C optimized for microcontrollers based systems, which is very crucial while you're stepping your step into the embedded systems programming. And then hands-on experience with embedded systems, like working directly with hardware simulation boards like PICSimLab as shown in the image. Configure parts, read sensors, control actuators, debug embedded systems, and whatnot. Build real world projects. Apply your learning by creating embedded solutions such as a washing machine controller, a mobile phone, and etc. etc. So, mine one was the washing machine controller. The topics discussed around this internship was the data types, the characters, the boolean, the floats, the double, the integers, and not only data types, the modifiers made be signed or unsigned, the qualifiers, the consts, the volatiles, and the loops, which is very important while you're working with embedded systems because the timers and the loops are a crucial part for your project. And then jump, then decision, then storage classes like auto, register, static, extern, and derived structures and unions, and user defined data types. These are important ones like enums, type diffs, arrays, and pointers playing an important role in throughout your C embedded programming. And functions, a reusable block of code, and a number of times it can be used like a functions and strings and macros. So there are four types of embedded systems. The first one is standalone embedded systems, then comes the real-time embedded systems, then comes the network embedded systems, then comes mobile embedded systems. So the very first one, the standalone embedded systems. The standalone embedded systems, it operates independently without needing a host system, such as a computer or an external processor, which directly displaying data or making changes on the connected device. That is independently working without needing a host system. The input is received through parts in the form of analog or digital signals, and after performing the required calculations and conversions, the output is shown on a connected device. If you take examples for this, there are various examples like a washing machine, a mobile phones, etc. Then comes your real-time embedded systems. Now, the real-time embedded systems are designed to produce outputs within specific time constraints, with a short span of time or a specific time constraint when it's provided to this embedded system. It works upon it, making them ideal for time sensitive tasks. If you take the types, there are two types: soft real time systems, hard real time systems. Deadlines are important but not critical. This is for soft real time systems. Tasks must complete eventually, even if you are not meeting a deadline. Example, computer audio system. Now, hard real time systems. Strict deadlines must always be met. Any delay can cause failure. Example, an aircraft control system, crucial for life saving. Then comes your network embedded systems. Network embedded systems involve programs operating within devices that are interconnected, typically managed by a microprocessor or a microcontroller. Now, as the name suggests, network embedded systems. these are managed by microprocessors or microcontrollers. So these systems rely on networks, which may be either local area networks, your LAN networks, or your WAN networks, wide area networks. As these systems are connected to each other on a single network, they are known as network embedded systems, and that is what makes them possible to manage by a microprocessor or a microcontroller due to this single network they all are connected within. For example, if you see an office or a tech park, security systems are typically examples where devices are linked through a centralized network and managed collectively. All the security systems of a particular tech park or an office are connected to a single network, and that single network is managed centralized, where a single person or a single host system can manage and make any changes and control all the security systems throughout the office or a tech park. Then comes your mobile embedded systems. Now, what is this? A mobile embedded system refers to portable devices that operate using embedded technologies. Mobile, the name suggests, a portable device that can operate using embedded technologies. Your mobile is also an embedded system, by the way. So, despite having limited memory and features as compared to higher end computers, their ease of portability makes them widely useful and accessible. And that is exactly why we have our mobiles, a portable device, always with us. Example, their mobility, of course, is what makes them mobile. Example, laptops, calculators, or mobile phones, or any handheld computer which is portable. Now, let us explain you for the last but not the least and the most interesting part of this, the project. So first and foremost, let's look into the project requirements. The project requirements involved when I was working upon this, I had to be vigilant about them. The first one, this project focuses on simulating a washing machine using PICSimLab, aiming to replicate real-world washing machine functionality in a virtual environment. And if you know little about embedded systems, PICSimLab is what let us do that. And second, using various switches in the keypad to do the operations on the washing machine. Of course, when you are simulating it, even if it is in a virtual environment, let us have it as much as possible to look and work as a real world example. Then comes the third one, using CLCD for displaying options and time left to complete the process. Using timers for tracking time left to complete the selected process, etc., is what the important stuff we'll be learning and doing in the project. 4. Using motor for representing the ongoing process and using the buzzer to indicate door status and program completion. So the tools used in this internship were MPLAB IDE for the environment and XC8 Compiler and PICSimLab. The XC8 Compiler to make the file, then to make it work in PICSimLab. We'll look into it further in our project. So MPLAB XID, it's a free cross-platform integrated development environment, as you all know, for programming like PICSimLab, DSPIC, AVR, and SM and SAMCOM microcontrollers, and it provides powerful features, querying, debugging, simulation, project management, whatnot. Like if you are into this, you'll know the importance of MPLAB XID. Then comes XC8 Compiler, specifically for 8-bit PICs and AVR microcontrollers, high performance and supports integration with MPLAB XID. That's the reason I use it here. Now, coming to PICSimLab, the most important and the interesting part which I learned in this internship. So it's a graphical simulator designed for simulating PIC microcontroller based circuits and interfacing them with real or virtual hardwares. So it actually allows users to test and debug embedded applications without physical having hardware, supporting integration with compilers like MPLAB XC8. I was able to do that as smooth. And now let's take a pause here and go and look into our project. Let's see its code, its working, and then come back to its various parts where we'll discuss about its weakness, threats, strengths, and opportunities. So let's get there and get back here. Let's now see a demo of our project. So here is our file. This is the project demo model, and I'll be loading my hex file now. Yep, so here you see, if you press key 5, you will power on the power washing machine. Let's switch it on, and yes, it's working. This is washing machine programs like daily, heavy, delicates. So we have used 12 different type of programs. The key 4 toggles all the programs. If you see, machine programs like wool, bed sheets, rinse, dry, wash only, aqua store, so everything can be toggled by key 4. Now if I long press my key 4, it will switch between these. Now comes the water level programs. Total I have kept 5 different types of programs for water levels, from auto to max, high, low, and mid. Let's select one. Yep, let's select the water level as high. Now for selecting, I'm switching with key 4, and let's yes. Now my switch 5 would work as a start button, and my switch 6 will work as a stop button. It will return to the last program, which was our water or washing program. So now let's use key 5, which is RB4, to start the machine. Now if you see here, it's showing you the function program, and it shows the time for you. Now you can see there as key 6 pauses the whole machine. Let's check the functionalities. This is the gate, the door of the machine. So if you're clicking upon it, like if you are doing toggling with that, it takes it as a toggle of your door, and it shows here. So if you see here, if it is in rinse, the timer continues, and yep, wash completed. Now the rest of the total time will be a spin. Now let's go to our code part. This is our code base, where our whole source files and all the machine programs are here. Now let me just check. Okay, yes, all the files are there. Main C, timers, CSC, yes, perfect, all files are here. And let's see here. See, this is the array input of 12 different types of washing programs, and comes the 5 types of water level programs. Then let's check down. Now here you can see the printing of the CLCD programs like washing machine power on, freeze key, etc. And you can have a look through for the code base. Here if you check, it is the water level setting program. If we are pressing the keys, then it toggles between the, like, see, switch, stop, start. So that is the functionality added here. This is the main break part of the loop. for the washing programs displaying, we have used this, like continue, break statements, etc. to control it. This is the power on screen. Like in CLCD, since it's turned on, how long it is, like since we are turning on the power on of the washing machine, it displays it. Now washing program display reset. So this is it all over for code base. Okay, so as now we have seen the project itself, let's speak about its weaknesses, threats, strengths and opportunities. In weaknesses, I could say limited exposure to real hardware, because if it's only simulation, basic level project might not reflect advanced embedded systems. But yeah, I learned a lot. Dependent on guidance, limited opportunities for independent innovation, and time constraints may have restricted deeper learning or explanations. But yeah, that was much more what I wanted to learn from this. Threats. Rapid technological changes in embedded systems make certain tools outdated. Yes, a threat. High competition in embedded systems roll with candidates having hardware experience. Lack of access to physical hardware, maybe. Coming to the strengths, gain hand-on experience with real-world embedded systems. Improve C programming skills in a hardware interfacing context, of course. Learn simulation and microcontroller programming, specifically for PICS16F877A. Understood the classification and application of embedded systems, soft versus hard real-time ones, and developed problem solving and debugging skills. Coming to threats, as I covered, and then to opportunities. Scope to work on more advanced real-time embedded systems, example robotics and IoT systems, and of course this is what I would be looking forward after this. An opportunity to enhance skills in RTOS, assembly or embedded Linux, of course. Can pursue certifications or projects based on microcontrollers or ARM context, and future internships or job roles in embedded product development. So that's all what I had to say for today. Coming to the conclusion, through this internship I was able to gain hands-on experience in embedded systems, develop, understand the importance of C programming, and explore various types of embedded systems. Work with the PIC16F877A Microcontroller and simulate a washing machine system using industry relevant tools. Exploring various types of embedded systems and identifying their appropriate use cases. And that's all for today.